Hi guys, in this video what we're going to do is going to look at something called composite functions, and I'm probably just going to do an example just to show you how this works. So essentially what it is we're running a number or an algebraic expression through two functions. So you can see here what we have two functions here. We have f of x, which maps onto 2x plus 3, and we have g of x, which maps onto x squared plus 4x. So first thing we're going to do is just put f of 3 through, and remember how we do that. Wherever we see a x in the f function, we're going to replace it with a 3, and if we do that, we're going to end up with this. So we're going to end up with 2 by 3 plus 3. 2 by 3 is 6, 6 plus 3, and we end up with 9. So f of 3 is equal to 9. We've done this before. G of 3, exactly the same sort of idea, apart from instead of putting the 3 through the f function like we did here, what we're going to do is going to put the 3 through the g function. So it's just a different function, that's why it's labelled g. It's just to differentiate between which function we stick it through. So we now have g of x is here. We want to put 3 through. Wherever we see an x, we're going to change it for 3. So this time it's going to be 3 squared plus 4 by 3. Work it out, we get 9 plus 12. 9 plus 12 is equal to 21. Now, we've done all this before, not a bother. And we're going to take this to the next level, where we're going to combine these two functions and put an expression or a number through them. So let's have a look at fg3. Well, what we have here, what we're saying here is we want to throw the 3 through the g function, and once we've done that, whatever the answer happens to be, I want to throw that through the f function, and that then is the fg of 3. So the thing to remember here is whatever's closest to the bracket is the function that we use first. So g of 3, we've already worked that out. Look, g of 3 we've already done over here. So we've got g of 3 comes out to be 21. And what we're saying now is that whatever that answer is, this g of 3, we're going to throw it through the f function. So this now is going to come down to be the f of g of 3, which we've already worked out, which is 21. Which now means I'm going to stick 21 into my f function here. So let's do that. So I'm going to get 2, okay, by x, which is 21 plus 3. So 2 by 21 plus 3. If I work that out, I get 2 by 21, which is 42, plus 3, which is equal to 45. Which means that fg of 3 is equal to 45. So just go through that again. fg of 3. G of 3 is first because the g is the closest to the bracket. I've already worked this out earlier on in the slides, that's 21. So whatever the answer of g of 3 is, which is 21, goes into the f function. So fg of 3 now becomes f of 21. I then put the 21 through my f function, which is 2 by x, and wherever I see an x, I'm going to replace it with 21 plus 3, work it out, and I get fg of 3 is equal to 45. Now I'm going to do gf of 3, which means this time, because the f is the closest to the bracket, we do that first. Again, we've already worked this out, so we've got an answer of 9 here. And this f of 3 is equal to 9. I'm going to stick through the g function. So this now is going to say, well, I've got g of 9. I'm going to look at my g function, and my g function states that it's going to be x squared plus 4x. So the number I'm going to stick through now is 9, because that was the answer to my f of 3. So let's put that through, and that's going to be equal to, and we're going to end up with x squared, so 9 squared plus 4 by 9. So that's going to be 81 plus 36, and 81 plus 36 is 117. And that there is my GF of 3. Something important to note here, guys, is look, my FG of 3 is not equal to my GF of 3. This one is 45 and this is 117. This will generally be the case. So what exactly is a composite function? Well, the easiest way to explain it to you is, instead of going through like little baby steps or little hops here, so see we do x by f of x and then we do g of x, what we're going to do is we can combine the f of x and the g of x, and we'll go straight from here to here. Now you might have noticed that we have a bit of a weird sort of notation here with this g and this sort of O f of x here. That's exactly the same as what we did before with the g f of x. It's just another way of writing the same thing that we did on the previous slide. So you can see what we have, just give an example, we have f of x equal to 2x plus 3, we have g of x equal to x squared plus 4x. What is g? And then we have this symbol f of x, and we can change it straight back to the symbol that we like if we want. So we can say this is g f of x, and we are just going to do exactly what we did before. So first of all, we have to do is we have to f of x, because the f is closest to the x, and we know what the answer to that is. We've got no numbers, so what we have here, the f of x is 2x plus 3, which means that in my g function, what I'm going to do is I'm going to put the answer, which is 2x plus 3 here, because when I put x through the f function, all that's going to happen is the x gets turned back into an x, so I have x goes through, so 2x plus 3, so my answer is just 2x plus 3. That there is my f of x. I'm now going to put that through the g function and just tidy it up a bit. So my g function is x squared plus 4x, so wherever I see an x, I'm going to replace it with 2x plus 3. So I'm going to get 2x plus 3 all squared plus 2x plus 3. So again, just to show you what I've done, this is my expression that I want to stick through the g function. The g function states x squared plus 4x, so wherever I see an x, I put this expression in. I'm going to get x, which is 2x plus 3 all squared, and then I've got plus the 4x and plus 4 by the x here, which is 2x plus 3. I'm going to tidy it up, and 2x plus 3 all squared is 4x squared plus 12x plus 9. Then I'm going to get this bracket out here, which is going to be plus 8x plus 12, and just collect all the terms together and we'll all be done. So we've got 4x squared, that's just on its own, so that's fine, 4x squared. Then I have the next one, which is 12x plus 8x, which is plus 20x, and the last one then is the numbers that are left, which is plus 9 and plus 12, which is plus 21. And that there, guys, is g o f of x here, and that's what it's equal to. Now I'm going to do it the other way around. So we've got f and this little symbol g of x. We're going to put it into the notation that we like, which is f by g of x. Now that means that we've got g of x first. Okay, so g of x, we just have a look. We're going to stick whatever x the g of x function is through the f of x function. So the g of x is just x squared plus 4x. So f of x squared plus 4x, and that's now going to go through my f function. So wherever I see an x in my f function here, I'm going to replace it with an x squared plus 4x. So 2, the x is going to be replaced by this, and we have the plus 3 at the end. So that is equal to 2. And what we now have is x squared plus 4x. And we then got the plus 3. So notice again that we have 2, x, and that's our expression that's going in for the x. We have the plus 3, and there's the plus 3. And we're going to tidy it up a little bit. So we're going to end up with 2x squared plus 8x plus 3. And that there is my f g of x. Okay. Notice again that this is not the same as this, and this is generally the case. Okay, so let's have a look at another example here. So what we have is we have the two functions f of x and g of x, and we've been asked to calculate g f of 2 and then f what looks like squared x in terms of x, and we're going to check to see if these two things are equal to each other. We'd assume they're not going to be, because it's not happened to be the case for the previous ones that we've done. Okay, so f of x equal to 3x plus 2, g of x equal to x squared minus 1. So the first thing we want is, let's have a look, first thing we want, apologies, is we want g o f of 2. Okay, not a bother, so we're going to change it into the notation that we prefer, g f of 2. F of 2 is the first thing that we have to do. So see f of 2, I'm going to stick 2 through this function, and I'm sure we can do this in our heads. So we can see that it's 3x plus 2. So 3 by x, which is 2. So 3 times 2 is 6. And 6 plus 2 is 8. So we're going to end up with g of 8. Now we're going to put the 8 through the g function, and again, it shouldn't be too difficult to do here. Hopefully you can see that it's x squared minus 1, so my x is 8 here, so 8 squared minus 1, so g of 8 is going to be equal to, I'll put it in anyway, that's going to be 8 squared minus 1, which is equal to 64 minus 1, which is equal to 63. So there we are, that there is done, so that's part I. Then says express f squared x in terms of x. Okay. Now, you see over here, I've written this in blue for you. We can see that f squared x is not equal to f of x all squared. These are not the same thing. So we don't work out f of x and put it in. So f of x here, which is 3x plus 2, and then square it. What it's saying is, if you see this what we call a subscript of the 2, what that means is it means run it through the function of f twice. Okay, so just put it through twice. So it's the same as this really. So f squared x here is f of x. So what we're doing is we're putting it through the function twice. Now we know what f of x is because it's up here. So it's 3x plus 2. So we're going to put the function, and then we're going to put 3x plus 2 back into the same function. So essentially this is going to go back now into the f function. So wherever I see an x, I'm going to replace it with 3x plus 2. So all we're doing again is putting it through the same function but twice. Okay, so now what we have is 3. Well, the x is now replaced by the 3x plus 2, and then what we have is the plus 2, and if we work that out we get 9x plus 6 plus 2, which is 9x plus 8, and that there is f squared x. That's what that's equal to. The last one asks us to determine whether g f of x is equal to f g of x. So let's see if that's the case. So we'll start with g f of x. So g and f of x, if we have a look here, is 3x plus 2. So we can replace f of x with 3x plus 2. That means that we are now sticking 3x plus 2 through my g function. Okay, so it's now going to be x, which is 3x plus 2 squared minus the 1. So x, which is 3x plus 2 squared minus the 1. And let's tidy that up. So we're going to multiply out the square bracket, the binomial. If we do that, we get 9x squared plus 12x plus 4 minus 1, and tidy it up, we get 9x squared plus 12x plus 3. Now remember, in order to get rid of a square bracket, what we do is we square the 3x to get 9x squared, we square the plus 2 to get plus 4, we multiply two terms together, so we get 2 times 3x, which is 6x, and then we double. Now we're going to try the next one, which is f g of x over here. So let's just write that down. So now what we have is we have f, and g of x this time we know is x squared minus 1. And this time what we're going to do is we're going to throw this x squared minus 1 through the f function, which is 3x plus 2. So wherever we see an x, we stick x squared minus 1. So we end up with 3 by x squared minus 1. Then we've got the minus 1, just to show you again. So 3. X here is this expression x squared minus 1, and then we have the minus 1 at the end, minus 1. Okay, multiply it out. We end up with 3x squared minus 3 minus 1. And 3x squared minus 3 minus 1 will go to 3x squared minus 4. And hopefully, guys, you can see that gf of x is not equal to fg of x. So we can write that if you want. So gf of x is not equal to fg of x.